Okay, 3A, 2 through 7. Number 2, in Figure 2, there were more families. Were there more families between 10,000 and 11 or 15 and 16? What would you say? I would say 10,000 to 11,000, right? The 10 to 11 box is a lot taller than the 15 to 16 box, right? So it looks like this. So 10 to 11 would be right here, and then 15 to 16 would be right here. Get it? 3. The histogram below shows the distribution of final scores in a certain class. Which block represents the people who scored between 60 and 80? B. 10% scored between 20 and 40. About what percentage scored between 40 and 60? 40. How'd you get that? So you add up, yeah. So 10%. Oh, wait a minute. What did you say it was? 40? Isn't it 20? It should be 20. Block D is 10%. So block C is twice as tall, so it should be 20%. What percentage scored over 60? So 10 and 20 makes 30. So D and C represent 30, which means B and A represent 70. We get that? Okay. Below are sketches of histograms for test scores in 3 different classes. The scores range from 0 to 100. A passing score was 50. For each class, was the percent about 50, over 50, or well under 50? So for A, 50 above or below the average score. Or sorry, not the average score. The percent who passed. Over 50. Okay, for B, under 50, and C, about 50. One class in exercise 4 had 2 quite distinct groups of students, with one group doing rather poorly on the test, the other group doing very well. Which class was it? I would say it would be B. Distinct groups, meaning they're quite separated. So A, we had a few kids that did poorly and a lot of kids that did well. But B, there's a huge separation. Which class do you want to be in? Okay. I think it depends on who you are, right? If you're a really studious student, B is the one to be in. Right? If you're not going to totally fail, you want an A. But it just depends on who you are. 6. Were there more people with scores in 40 to 50 or 90 to 100? So 40 to 50 or 90 to 100. Which column is taller? So 40 to 50 and 90 to 100 have the same width. They're both a width of 10. So then we just look at how tall the column is. 90 to 100 is much taller. An investigator collects data on hourly wage rates for 3 groups of people. Those in Group B earn about twice as much as those in A. Those in C earn about $10 more an hour than those in A. Which group belongs to which group? So number 1 has to be B. And number 2 has to be A. And number 3, C. So an important thing to note here, if our histogram looks like, that's not a very good one. If our histogram looks like this, and everybody's wage doubles, what effect is that going to have on the graph? It's going to, so let's look at a particular column. So this group of people here, they earn a certain amount. If I double that amount, then that group is going to move to the right, right? Twice as far away from 0 as they started. Well, this group here is also going to move twice as far, but they're going to move much further than the other group because they're further away from 0. So when I double, it's going to stretch this graph to the right. Stretch it. Not slide it, but stretch it. And because the area under the curve has to remain 100%, it's going to be shorter. So when I double, it's going to look like that. Every column got stretched twice as wide, but they also became half as tall. Okay? But if I look at this same group of people, and instead of doubling their wage, I give them all $10 extra, what effect does that have? It's going to slide it to the right, $10. Do you see the difference? So addition and subtraction will slide. Multiplication and division will stretch or squish. That's going to be really important in this class. All right, that's it for 3A.